All right, for this video, we are looking at converting to vertex form from standard form of a quadratic. So those are our equation forms. Standard form, ax squared plus bx plus c. Vertex form, a times x minus h squared plus k, where a is going to equal a in both equations. H will equal negative b over 2 times a. And then once we solve for h, we'll plug that into standard form for x and solve for k. And then we could just rewrite vertex form. So that's one method, using these relationships. However, we also want to know how to do this with completing the square. And so we're going to show in this video how to complete the square when a does not equal 1, but we're going to preserve a. Unlike the last video, we divided it away. Now we want to preserve a by factoring so that we end up with vertex form. So the first step, if we have a problem like f of x equals 3x squared plus 12x plus 15, in order to complete the square and preserve a, what we'll want to do first is notice that all of these are divisible by 3, and that's a good thing. So we're going to want to factor our 3 away. But first, let's do something else. Let's set this equal to 0. So first step, a little more complicated than the last one. We're going to set this equal to 0. We're going to go ahead and subtract the 15 from both sides first. Just like in the last video when we isolated our x squared and x terms. We did that on the first video. So now we want to factor out this 3 so that what we have here is we have in our parentheses, we're going to factor out a 3 here, but we're going to complete the square inside the parentheses. So this is essentially this problem where we have to figure out, well, what is our number that we're going to add here? So just like in the previous videos, what we're going to do is we're going to take our b value, divide by 2, and square it. 4 over 2 squared is 4. And so we'll want a 4 in here. However, this is a really interesting situation. We're adding 4 inside the parentheses. However, the total that we've added on this side is actually going to be multiplied by 3. So we're really adding 12 to this side when we do of the equation when we do this. And so that's something to be aware of, so that when we add over here, we're not just adding 4 on the left-hand side of the equation. We need to add 3 times 4. Okay, so sometimes I'm not going to go into too much of that in this video, but basically thinking about what we're really adding here is we're adding 12 to both sides of the equation. Okay, 3 times 4. Okay, so let's simplify this. This is going to become negative 3 on that side of the equation. This is going to be 3 times. Remember, our pattern is that whatever this is, if we're going to have x plus 4 divided by 2, b over 2 on this one side squared. So we're going to have x plus 2 squared here. Well, this is looking a lot like vertex form. And actually, if we add 3 to both sides, we see that we get vertex form, where h equals 2 or negative 2, and k equals 3. So that's how we would transfer this to vertex form. And then we'll write our final function as f of x equals a times x minus h, or plus 2 squared, and then plus k, which was 3. You can actually do a check here using method 1. Did we do it right? So remember, if h is negative b over 2a, well, that's going to be equal to negative 12 over 2 times 3, which is indeed negative 2. And then k would equal f at negative 2, which is, we're going to go to our original function and plug in negative 2 for x. and solve. And that's going to be 3 times negative 2 squared is 3 times 4, that's 12. 12 times negative 2 is minus 24, and then plus 15. So 12 minus 24 is negative 12. Negative 12 plus 15 equals 3. And yep, that's what we got. That's how that works.